For this experiment, we will need the Catter's pendulum, which consists in two different masses attached to the extremes of a metal bar. We will also need cables for the switch box. We will need a vernier caliper. We will need the switch box. We will also need the Pascal interface and the photodetector, which will allow us to detect each oscillation. We will also need the computer for monitoring the data, and we will also need a rail to change the position of the masses. The next step is to plug in the Pascal interface to the computer, so we connect the cable that goes to USB output. We plug in the switch box to the electrical outlet. And then we connect the switch box to the photodetector. At this point, we can see that a light is on in the photodetector, which means that it's already on. Then we plug in the Pascal interface to the switch box so we can monitor the output through the computer. Now we see that we can change the position of the masses in the rail. So now we set a distance. Now we measure it using a vernier caliper tool. And we do the same for both masses. Now we hang the pendulum. And we set the photodetector in position. For this, we make sure that the pendulum is in the midpoint between the detector and the light bulb. We also need to make sure that the light is hitting the bar and not the masses. As an additional note, the pendulum should not be shaking. In this video you can see that the pendulum is shaking a little bit, but then you have to stabilize it. Otherwise you will get an error coming from the shaking. To make sure that the pendulum is oscillating properly, you need to use the center finder. So if you see that the position of the center peak is changing too much, you should reconsider moving the sensor gate. And now we see that through each oscillation, the peak remains almost in the same position. So now we click stop. And if we go to the data collection tab, we can see a table at the left and an empty plot at the right. In the table at the left, we are going to include the distance between the knife edge and the mass we measured with the vernier caliper. In order to start taking data, we need to start oscillating the pendulum. For this occasion, the lower mass is the metal. We go back to the graph tab, we press record, and we start recording data. So we are going to stop. The next step is to use the coordinates tool. We click on it and we drag it up to the top of the first peak and the final peak. Then we use the calculator to find the difference between these values. Then we take this value and we put it into the metal down column, and it will position the value in the plot at the right. Now we have to flip over the pendulum and repeat the same measurements. So this time we will have the plastic mass at the bottom. After repeating the measurements, we are going to take the Catter's pendulum down. We will put it in the rail and we will change the set distance again. We annotate the new value in the table. We give a little swing to our pendulum and we record data again for at least 11 points. Then we will be able to see the new points in the plot. After doing this experiment with 10 different distances, we are going to get a plot like this. We're going to find the crossover point. Once we have identified the crossover point, we will set our masses at that distance. And we are going to take at least 5 measurements with metal down and 5 measurements with metal up. Then for each of these measurements, we are going to raise the pendulum 5 degrees, then 10 degrees, and then 15 degrees. And we are going to record data for 5 cycles, 10 cycles, 20 cycles, and 50 cycles.